name is Olivia Lim. I'm a Ph.D. student at the University of Montreal at the Trottier Institute for Research on Exoplanets, and I work on the TRAPPIST-1 system. So TRAPPIST-1 is an exoplanetary system made of 7 Earth-sized rocky exoplanets orbiting around a small red dwarf star in our solar neighborhood. And the TRAPPIST-1 system is super interesting for so many reasons, but one of them is that 3 of the 7 exoplanets are in the habitable zone of the system. So the habitable zone is the region around a star where the temperature is not too cold, not too hot, just right for liquid water to exist at the surface of a rocky exoplanet. So we used 2 instruments on the James Webb Space Telescope to look at the TRAPPIST-1 planets. We used NIRSpec and NIRISS. So NIRISS is the Near Infrared Imager and Slitless Spectrograph. It's a Canadian-made instrument aboard the JWST. And we used these 2 instruments to look at very particular events called transits. So a transit is when a planet passes in front of its host star from our point of view. And when that happens, the light from the star can get filtered through the atmosphere of the planet. And then when we see that filtered light, we can disperse it into its different wavelengths, or different colors if you prefer. And this filtered light tells us about the atmosphere of the planet. So far, we have a handful of transit observations of TRAPPIST-1 with JWST. The goal of these observations was to determine if the planets in the TRAPPIST-1 system have an atmosphere or not, because we don't know that yet. And with the data that we have right now, we cannot say that we detected any atmosphere on the TRAPPIST-1 planets. But it's far too early to draw any other conclusions right now. We know, for example, that there are effects that can contaminate our data. For example, if the star has spots on its surface, it can contaminate the data. That's a thing that we know for sure. And it's also very likely that the star has spots on its surface. So the next steps in our research, first of all, we'll have to finalize our analysis. We're not completely done looking at the data that we have right now, but looking even further in the future, we'll have to get more data. It's unfortunate to say, but that's the reality. We'll need more data to be able to disentangle stellar contamination effects from any potential planetary atmosphere effects.